All right, so this is problem 13.20 from mastering. So let's first draw our barometer to get some kind of idea of what we're working with. That is the wrong color. Let's try that again. All right, let's go. So here's the inverted tube, and here's the tray that's going to hold the fluid. And what we're doing here is basically you would fill this tube up. Well, you'll see in a minute. This would not be practical because this tube's going to be very long. This one, but basically you somehow remove all the air from the top part of the tube up here. So you have a vacuum up here at the top, and this whole thing is going to be filled with fluid. And and the tray down here is also filled with fluid. And the thing that we talked about in class is how, let's see if I can draw this line along here. What we talked about in class is that the pressure where the atmosphere interfaces with the fluid is going to be the same here as here, because these 2 points in the fluid are at the same height. And since there's a vacuum up here at the top, it's the empty space, there's no pressure up here, then the pressure from the fluid pushing down this column of fluid is going to be equal to the atmospheric pressure. What that means you can do is you can apply the gauge pressure equation, and that is P equals rho GH. And the question was, what is the height going to be? So we'll divide both sides by rho G to get that. So we're going to put in pressure divided by rho G. And picking a fluid less dense than water, not a good idea for a barometer. It's not recommended because it will make you have to have a taller tube. And what I was about to say earlier is you'd take the tube and you'd put your thumb, or like you'd fill it up with fluid, like right side up, and put your thumb over it and flip it upside down. But what you're about to see is that you would have to do some kind of tube with a pump to suck the air out, some kind of vacuum pump up here at the top, because that just wouldn't be practical with a tube that was in excess of 10 meters tall, which is, again, is what we're about to see here. Now, what we need to do here is pressure to be compatible with the other units present here, kilograms, meters cubed. G is going to be meters per second squared. We're going to need to do that pressure in newtons per meter or pascals. So we're going to do atmospheric pressure in pascals, 300 PA. Over, and I'll do the unit analysis in just a moment. Let's see, rho is going to be 900, and G is 9.8 or 9.81 meters per second squared. Mastering likes for you to be more precise. AP exam, not so much. You can get away with that. All right. Now, just over here somewhere separate, I'm going to do this unit analysis. Okay, so a pascal is not what I have written here, so let's fix that real quick. I got partway into this and realized I'd forgotten something very important, so let's try this again. So a pascal is a newton per meter squared, and that is going to be over a kilogram per meter cubed times a meter per second squared. Let's see, that meter and one of these meters will cancel out, so we're going to have kilograms over meter squared times second squared. And then we have meter squared in the denominator of the numerator and the denominator of the denominator, which is kind of a weird statement to make, but that's how it is. Now, something else we need to remember here is that a Newton is a kilogram times a meter per second squared, and that is because Newton measures force, and force is mass times acceleration, just like Newton's law says. So Newton's second law. So that's what we'll replace it with, is a kilogram times a meter per second squared, and that is going to be divided by a kilogram times, kilogram divided by, a second squared. Now, second squared appears in the denominator of both the numerator and the denominator. Kilograms appears in the numerator of both the numerator and the denominator. So the only unit that's left over is meters, which is good because we're solving for height. So that was the goal to begin with. So let's plug all this stuff in and see what we get. And that gives me a height of 11.49 meters. And that is well over 30 feet. So that would be a very tall tube. And hopefully this unit analysis was helpful to help you see. But I guess the big takeaway here is when you're doing pressure and dealing with other standard units like kilograms and meters and seconds, you need to be in pascals for this reason. Even if you don't remember all the unit conversion kind of stuff, you do need to understand that, hey, I need to be in pascals to do this. Hope that helps.